In this video, we're going to look at the acid-base properties of ions and salts. And so we're going to start with a little bit of review. But salts are just ionic compounds. And if a salt is soluble when in water, it will dissolve to form ions in solution. Now, cations of strong bases and anions of strong acids do not ionize water. That means they don't take hydrogens from water. So they don't affect solution pH. So, for example, the strong base, sodium hydroxide, the cation of a strong base, so the cation is sodium. Sodium will not affect water whatsoever, so it will not change pH. Hydrogen chloride. So chlorine is the anion of a strong acid. This chlorine's not going to affect water in any ways, so the pH won't change. However, cation of a weak base and an anion of a weak acid will ionize water and affect the pH of a solution. So let's look at this weak base, NaHCO3. Now sodium is the cation of a strong base, NaOH. As we just talked about, it's not going to affect anything. But HCO3 minus, it is the conjugate base of the weak acid H2CO3. So it will affect the pH. The way it affects pH is this way. Anions, they usually form basic or neutral solutions. Cations, they will form your acidic and neutral solutions. Alright, so let's just think about anions here. And really, any anion can be thought as a base, a weak base. Because if it's an anion, it has a negative charge. Well, we could just put a hydrogen with that compound. For example, Cl minus. Well, it is the conjugate base of the acid HCl. So anything that's an anion can be thought of a conjugate base of an acid. For example, if our general case here, A minus, which is an anion, it could take a hydrogen from water and reform an acid and produce OH minus. Right? And in general, the stronger the acids, the weaker the bases, the conjugate bases. And this should make a lot of sense based on our previous videos. We said that a strong acid has a very weak attraction between the hydrogen and the anion. Therefore, in its base form, it won't want to reform the acid because this was strong for a reason, so your bases are either going to be neutral or weak. Well, let's look at our extremely weak acids here. So these extremely weak acids, they have a very, very strong interaction between their hydrogen. Therefore, if you have the basic form, these basic forms are very strong. They want to attract a hydrogen. So in general, if you have something that's strong, its conjugate will be weak. If it's weak to begin with, the conjugate will likely be weak as well. All right. So for anions, if you're the conjugate base of a strong acid, you're not going to affect the pH. You're not going to reform your acid. However, the conjugate anion that is the conjugate base of a weak acid will form a basic solution. So F minus, right? If you put a lot of F minus in solution, or you put like sodium fluoride, for example, NaF. NaF will break apart into sodium molecules and fluorine molecules. That fluorine is now a weak base, and some of it will go and form weak acid because of equilibrium. When it forms weak acid, it's going to be forming OH minus because it's going to be taking the hydrogen from this water. We can calculate the amount of OH minus using an ice table. Then we could calculate pOH, and from there we could calculate pH and determine the pH of the solution. To do this, you really have to know what are your strong acids. Because if you know your strong acids, you know which ones are not going to be basic here. And everything else is more or less a weak base or a very strong base. Alright. Now, in the previous problem I was just talking about if we have fluorine minus, the only way to solve that equilibrium problem is to know Kb. However, in every standard textbook or reference you would find, you're only going to find Kas. And that is because from a Ka you can actually figure out what Kb is. So let's look at this first equation. We have an acid. Our acid plus water goes to our H3O plus and A minus. We have an equilibrium constant for this. We should know Ka. And then we can take our conjugate base. I have it act like a base. We get Kb. Now we could add these equations together. So let's do that. And we get 2H2O goes to H3O plus OH minus. Because the A's cancel out and the HA's cancel out. They are found on different sides of the equation, so they would cancel out. Now, in a previous video, we talked about when you add equations, you actually multiply Ka by Kb. When you do that, you see that Ka times Kb equals H3O plus times OH minus. Or, that's Kw. So Ka times Kb equals Kw. And now you can see that Ka and Kb are inversely proportional to each other. So the stronger your base becomes, the weaker your acid must become, because multiplying these two together must give you Kw. So let's say that you're dealing with a compound that's a metal. How is a metal going to affect a pH, a metal cation? And small, highly charged metals are actually weakly acidic. And at first, that doesn't make a lot of sense. Why should metals be acidic? Metals aren't bases. Well, when you put a small charged metal in solution, what happens is that it gets surrounded by water. They have ion hydrogen bond interactions or ion dipole interactions, if you remember all the way back from chapter 11. So here we have aluminum, and it's having 6 interactions with the oxygens of water. Now, if you take organic chemistry and maybe biochemistry as well, you will get more in depth into the chemistry of what's going on here. But basically, when these water molecules are attracted to this iron, the strength of interaction between the hydrogen and its water molecule becomes even weaker. When that happens, a separate water molecule can take away that hydrogen easier because this bond has become weaker. When it does that, you're forming a slight amount of H3O plus in solution, and your pH will drop. And this is actually a big problem when it comes to making beer. When you make beer, you have to make sure you watch your pH. Those beer makers who are situated in places that have a lot of metals in their water have to be very careful to adjust their pH before making their beer, or you're going to have foam differences, you'll have flavor differences, stuff like that. So let's say you have a salt solution. How do you know if your solution is going to be acidic, basic, or neutral? Well, if your salt, the cation and anion, if they do not act like an acid or a base, that's going to be neutral. So sodium chloride, sodium's the cation of a strong base, chlorine's the anion of a strong acid. So these are going to be neutral. So that will make a neutral solution. pH won't be changed. Now, if the cation does not act as an acid, but the anion is a conjugate base, then it'll form a basic solution. For example, NaF. We just talked about sodium, but fluorine is the conjugate base of the weak acid hydrofluoric acid. So when this breaks apart in solution, you'll have sodium, Na+, and F-. Some of that F- will reform HF in solution. It'll get that hydrogen from water, therefore it'll make some OH- molecules, which will raise the pH, making a basic solution. Now, if you have the cation that's a conjugate acid of a weak base, and the anion that's a conjugate base of a strong acid, you're going to form an acidic solution. And that's because if you're the conjugate base of a strong acid, you don't want to reform that acid. Remember, strong acid means extremely weak base. But a weak base will form a weak acid. So, for example, NH4 will donate some of that hydrogen to water molecules and remake NH3. When it does that, it's making H3O plus molecules, which in fact lowers your pH. If your salt cation is a charged metal ion, and your anion is the conjugate base of a strong acid, again, you'll form acidic. If you're base of a strong acid, you're not doing anything. If you're a metal, as we just talked about in the previous slide, you're going to make your solution slightly acidic. So with these 4 guidelines, you can determine, if I give you a salt, you can predict, am I going to have a basic solution, an acidic solution, or a neutral solution. And that's it for this video. I will see you in the next video.